Recently in one of my weekly live streams, which I've been doing every Monday night at 5 Pacific, 8 Eastern, I went over the definite integral properties, more specifically some of the more important common ones that are going to come up a lot. And I took these directly from my integral calculus cheat sheet, which you can get more information about and go buy for yourself. It's available for instant download at the link down in the description or the pinned comment below. But I thought you would find the portion of this live stream pretty helpful, since these are some of the more important definite integral properties. So I wanted to show you what those look like. And what we're going to be doing is applying those in order to simplify an integral, which is something that you could apply whenever you're dealing with a more complicated integral expression to simplify the problem down into something that would be easier for you to solve. If that sounds good to you, be sure to stick around to the end of the video, and let's go ahead and jump into the example. If the integral from 1 to 5 of f of x dx equals 10, and the integral from 1 to 5 of g of x dx equals 2, we're going to find the integral from 1 to 5 of 8 minus 3 times f of x plus 10 times g of x dx. So this is going to use a few different integral properties. So again, if we go back over here, we have these integral properties that were covered on my Calculus 2 study guide. Like I said, if you do want to get that Calculus 2 study guide, I do have a link down in the description if you want to grab that. It's available for instant download. You can get a PDF of that pulled up and have that available as you work through your problems. But in this case, we have a couple of different properties, again, that we're going to want to use. So the last example that we did, we went from 3 separate integrals and used these properties to combine them into a single integral. Well, in this case, we actually want to do the exact opposite, because what we are given here is some information about what the integral from 1 to 5 of just f of x dx is. We know that this whole thing, if we can get this somewhere in our equation, we know that this is all equal to 10. And similarly, we know that if we can kind of manipulate this this integral here to get it so that we just have the integral from 1 to 5 of g of x dx, we know that we can replace that whole thing with 2. We don't just simply have the integral from 1 to 5 of f of x dx or the integral from 1 to 5 of g of x dx anywhere in this integral, right? Because we have these other constants being multiplied by f and g. We have this other number being added in here. So we've got a lot of other stuff kind of along with the f of x and the g of x that we actually know something about. So what we're going to want to do is use these different integral properties that are covered on my Calculus 2 study guide in order to split this integral up into smaller, simpler pieces. Because what we're hoping to do is get something that looks like just one of these two things so that we actually know the value of that. So the first step in doing that is probably going to be to apply the integral property that says if we have the integral from a to b of f of x dx, and we are adding that to the integral from a to b of g of x dx, we can combine these into a single integral, which is the integral from a to b of f of x plus g of x. Well, the interesting thing about these integral properties is we can also go the other way. We can start with the integral of something plus something and split it up into these two separate integrals of the integral of this first thing plus the integral of this second thing. So that's what we're actually going to do here. We're going to take this, and we have 3 separate pieces here that are being added or subtracted, and we're going to split this one integral into 3 separate integrals. So to do that, we're going to take, keep in mind with this integral property here, the bounds remain the same. This basically, applying it the direction that we're applying it, it means that the bounds of each of these two integrals are going to be the same as what they started with. So we're going to take the integral from 1 to 5 of our first piece, which is just 8, and then put a dx on there. And then we're going to do minus the integral from 1 to 5 of 3 times f of x dx, and then plus the integral from 1 to 5 of 10 times g of x. So this, split this one single integral into 3 smaller, simpler integrals. The problem we have now is these pieces here with our f of x and our g of x they aren't just f of x and g of x like we were given. They still have these constants being multiplied. Well, another one of the integral property, or one of the integral properties that's on my study guide, is that if we have the integral from a to b, whatever a and b are, of some constant times some function, the constant can be pulled out. So this is going to be equivalent to the constant times the integral from a to b of whatever the function that was being multiplied by that constant is. So in this case, we have this first integral is not going to be changed yet. We'll deal with that in a moment. So we'll keep the 8 there. But then we have this 3 times some function f of x. Well, if we look back to this integral property here, we should be able to pull, if we go from this version of the property to this version, pull that constant out of the integral and have it times the integral out front. So what we can do is we can take this 3 and move it out in front of the integral, and then have 3 times the integral from 1 to 5 of just f of x dx. Then same thing here, we have this constant 10 times our function g of x. We can pull that out of our integral. So from 1 to 5, we'll have 10 times the integral from 1 to 5 of g of x dx. Okay. Now we still need to deal with this integral that is just the integral from 1 to 5 of 8 dx. So this is kind of weird because there's no function, or there's no variable, there's no, f of x or g of x that we were given some information about. So how do you deal with just the integral of a constant? Well, that is one of the other properties that's on my Calculus 2 study guide. So the property I'm referring to is the one that says the integral from a to b of a constant c with respect to x is just going to be the constant c times your upper bound minus your lower bound, b minus a. So as a result, we can apply that property to figure out that we're just going to get whatever our constant is that we're integrating times the upper bound minus the lower bound. So that's just going to be, in this case, 8 times our upper bound of 5 minus our lower bound of 1. So 5 minus 1. That is going to simplify down to 4, or 5 minus 1 is 4, times 8 is 32. So we know that this integral here, the integral from 1 to 5 of 8 dx, is just 32. Okay, so now we can deal with these other two pieces, because now we got these two pieces to be exactly in the form that we wanted them to be, right? We have right here the integral from 1 to 5 of f of x dx, which is exactly what we were given here. We had the integral from 1 to 5 of f of x dx. And then we also have here the integral from 1 to 5 of g of x dx, which we were also given right here. Okay, so we know that this integral from 1 to 5 of f of x dx is just equal to 10. So we can replace this whole thing by 10. So we're just going to have 3 times 10. And then we know that the integral from 1 to 5 of g of x dx, this piece here that's in the box, is just equal to 2. So we're just going to get 10 times 2. So then we can simplify these pieces here. We're going to get 3 times 10 is 30, plus 10 times 2 is 20. Remember, order of operations, we got to do our multiplication before we do our addition and subtraction. So we'll do the 3 times 10 and the 10 times 2 first. And then we will have 32 minus 30 is 2, plus 20 is 22. So this expression that we had here, the integral from 1 to 5 of 8 minus 3 times f of x plus 10 times g of x dx, is all just going to be equal to 22. Well, I hope you found that video helpful. If you did get some value out of that, please, it would be a huge help to me if you would go ahead and hit that like button down below and subscribe while you're down there as well, so that we can keep getting these videos spread out to more and more people and keep growing the Drake's Math Lessons community. It's a huge help to me and my channel, so I can keep making more videos like this. If you want to learn more about integrals or definite integral properties, I have made some other videos on this. Go ahead and click on one of these videos over here and keep on learning. Thanks, and see you next time.